Now you have this next question. Integral sine squared x times cos squared x divided by sine raised to the power of 5x positive cos cubed x times sine squared x positive sine cubed x times cos squared x positive cos raised to the power of 5x raised to the power of 2 times dx. So this is what the question looks like. We are expected to handle this. Foremost, what I wish to do is I would take sine raised to the power of 3x out. So that would mean this would give me sine squared x, and then this would give me cos squared x. So this is clubbed with this, and then I would take cos cubed x out, and I would get a sine squared x here plus cos squared x there, and this is raised to the power of 2. Okay, fair enough. And the numerator is sine squared x times cos squared x times the dx. Now this is equal to this will give me 1, this will give me 1. So I have integral sine squared x times cos squared x divided by sine cubed x positive cos is cube x raised to the power of 2. And what I would do is I would take cos cubed x out, and that would give me sine cube x divided by cos cube x positive 1 raised to the power of 2, and this is sine squared x times cos squared x times dx. Now sin x over cos x is tan x, so this is sine squared x times cos squared x divided by, this is going to be cos raised to the power of 6x times tan raised to the power of 3x positive 1 times the dx. Now I would make the following substitution. Before that, I can actually get rid of this. So this would give me sine squared x times, now 1 over cos x is secant x. So this is going to be 4 here, right? So that would mean secant raised to the power of 4x. So we can actually place that secant raised to the power of 4x there times the dx. Okay, so that part is done. Now what we can also do is I will have to place this 2 there. Now I would have to make a substitution. So this is actually 1 positive tan cubed x raised to the power of 2, right? Now if I make a substitution, say put 1 plus say tan x, or tan raised to the power of 3x is equal to say some t, then this would be 3 times tan squared x times differential of tan x is secant squared x times dx. So I would have to get this over here. So for that, what I would do is I already have cos raised to the power of 4x. So what I would do is I will say a sine squared x over a cos squared x there, and 1 over cos squared x, I'm going to write it as secant squared x times dx divided by 1 positive tan cubed x raised to the power of 2. Okay, Fair enough. Now if I were to have the substitution over here, this would give me, so 3 times tan squared x times secant squared x times dx, this is going to be equal to my dt. So this can be rewritten, this is over here, can be rewritten as dt over 3, so 1 over 3 comes over here, and 1 positive tan cubed x, that's going to be t, this is raised to the power of 2, you get the 2 there. Now this is 1 over 3 times integral t raised to the power of negative 2 times dt. This is 1 over 3 times t raised to the power of negative 2 positive 1, negative 2 positive 1, which is negative 1 over 3 t raised to the power of negative 1, which is negative 1 over 3 times t. But what is my t? 1 plus tan cubed x. So I'm going to use this part. So this is equal to negative 1 over 3 times 1 positive tan cubed x. So 1 positive tan cubed x, positive arbitrary constancy. Okay, so that is the solution for this question, and I would consider this to be the most easiest question from the past paper questions. Thank you, students. We move on to the next question.